Okay, so welcome to the video. We will be covering factorization, but the four types of factorization that we will mainly cover is to factorize using common factors, factorizing by grouping in pairs, factorizing using the difference of two squares, and factorizing a quadratic trinomials, right? So let's get started with factorizing using common factors. Now, the ideal factorization is that it's kind of the inverse process of expansion, of expanding a particular um, expression, right? And when we're talking about an expansion, right, this is an expansion and this is its factorized form. So to move from its factorized form to the expansion, you have to obviously multiply the a inside. And once you multiply the a inside, you can see that it should give you ab plus a, right? But how did we get to this point? If you think of it, ab plus a, as we call this type of factorization, common factor factorization, we are looking for the common factor. We are basically looking for the two things in each term. And remember, a term is a particular variable or a number or a constant or whatever, but it is separated. How do you see that we have two terms? It's separated by a plus or a minus, right? So in this case, you can see we have a plus, so we have two terms, and we have the first term and the second term. So when we talk about common factor factorization, we're looking at all the terms of that particular expression, and we're looking for what is common for all of them, the highest common factor. So the highest common factor in this case is a. So then we take out a, and that's why we place it in front, and then we create a bracket because we've just taken out a, right? And when we've taken out a, if you think of it, if I'd cancelled a here, you're left with just b. And if I cancel a here as well, you are supposed to be left with 1 because you still need to be able to get back to what you started with. And how can you get back to a, right? If you multiply a times 1. Anything times 1 would be that thing, right? And so if it was b times 1, it would be b. If it was 99 times 1, it would be 99. But in this case, a times 1 will give us a. And that is why it's b plus 1. Okay. So here are some stuff that I'd like for you to also try and like practice. So maybe take time to maybe stop the video and try and do all the rest if you've never done them before. So the ones that I will look at quickly as examples is the ones that are highlighted in red, and the rest are left for you to try on your own. So you probably stop the video and try it on your own. Okay. So now here is 6xy minus 2x, and that is equals to 2x, right? Why? Because it's equals to 2x bracket 3y minus 1, because as you can notice, 2 and 6 are in the same times table, if you could think of it like that. If it's in the same times table, that means that we can actually take them out. They are common, right? They have a commonality between the two. And the commonality of the highest common factor is just 2, right? So it's 2. And then also, we do see that for each term, we do have x. Therefore, we have x. So it's 2x. And then when we multiply it in, you can actually see it will give us the initial result, right? But how do you get 3y? We just take out x. We divide 6 by 2, right? So then it's just 3, so it's 3y. And then we took out, literally, remember, we took out 2x. So in actual fact, the only way we can get back to 2x is if it was multiplying by 1. And we do not change the sign, right? We do not change the sign, it's just minus 1, right? Because what we chose in front is a positive 2x, okay? And now here it's minus 3m minus m squared is equals to minus m, right? And this is equals to a common factor of minus m. Why? Because you can see that we do have two negatives, right, for both and m, right? So if we have that, then it's just minus m, and then what will be left inside is what we didn't use, which is the 3, right? And because it was a negative, right, we're taking out a negative m. When we multiply it in, it has to be a positive m, because then we'll be able to get negative m squared, and that is very important. Okay, and so when we look at the next one, it's at minus at squared. What is common here? You can see that in the first term you have at, and in the second term you do have at squared. So in this case, what you do is you take out at, and then when you take out at, then you will be left with 1 minus t, right? And you can check it again. When you multiply in, you'd see that it should go back to what we started off with. And then we have I. With I, it's 7x squared y plus xy is equals to xy, all in x plus 1, right? And you can see that would be the case. Just the last ones that I would like to do with you as you watch is that, okay, we have a to the power 2 plus a plus b plus 3a, right? Now in this case we have 3 terms, right? It's a trinomial, but then what can we do to get the answer? So if it's trinomial, we do have a in the first one, we have a in the second one, and we have a in the third one. So here the common factor is a, and then what are we left with? So now we took out 1a, so therefore we are left with 1a in the first term, and then in the second term we take out 1a again, so we just left with b, and then we take out a from the third term, but then we'll be left with just 3, right? And that would be your final answer for that. So if you look at the next one, you have xy minus 3x squared plus 2x. This is a trinomial again, but now what is common for all 3 of them? It is the x, right? So it's x, x, x. The numbers are not common, so now what can we say? We can say that x is our common factor, and then inside you'll be left with y minus 3x plus 2, right? And that would be the final solution for that. But now here, quite an interesting one. We have 3 plus 5m minus 2n. Now if we look at this, 3, 5 and 2 are not in the same times table. All of them are in their own unique times table, right? In times table. And also you find that with 3 there's no variable. With 5 we have the variable m, but then with minus 2 we have the variable n. So now the problem is every single thing is different. So can this be factorized? Yes, if you say it's 1 outside as the common factor, because everything does have a 1 multiplying it. 3 plus 5m minus 2n. However, this can be a factorization form of it, but because there's really no commons, right, other than 1, which is 1 we usually treat as an invisible number, then it actually just, in truth, 3 plus 5m minus 2n, right? Because remember, this 1 is invisible, and so if it's invisible, there's really no need to put it in the bracket and say it's 1 times 3, which is 3, 1 times 5m, which is just 5m, 1 times minus 2, which is just minus 2n. So it's still the same. So there's no common factors, and therefore you would not factorize it any further. Okay, that would be that one. Okay, so here is some other extensions of common factor factorization, and basically what I'd like you to do is to probably stop the video here and try out all of these particular exercises, so you can get a good feel about factorization, and also a very interesting observation that you'll have that will help you quite a lot when you get to grouping. Okay, so now we move on to factorizing by grouping in pairs. And so here's a very good example. Now you have a trinomial which is 3x to the power 2 plus 10x plus 8, right? Now you can agree with me that you could separate 3x squared plus 6x plus 4x plus 8 into, you can separate the 10 into 6x plus 4x, right, which is done over there. So you can agree with me that you can do that, right? So if we could do that, we have 6x and 4x. Why did I do that? If you think of it, 3 and 6 are in the same times table, and then we also see that 4 and 8 are also in the same times table, right? So what can we do? Why did I do it like that? Because in actual fact I want to create two different brackets. So there, when we have the two different brackets, if you think of it, we have 3x squared plus 6x, and here we have 4x plus 8, right? Now I have these two sides that I want to look at. Why? Now what I'll do is I would factorize, common factor factorization, right? And the common factor here is 3x, right? 3x, because 3x is the highest common factor for these two terms. So for these two terms, what is the common factor? It's 3x, and when you take out 3x, you'll be left with x plus 2. Okay, but then here again, what is the common factor for 4x plus 8, right? It is actually just 4, and so we would have 4 and it's x plus 2. But notice something here, we have x plus 2 and x plus 2, which is exactly the same. So if it's x plus 2 and x plus 2, thinking about what we just learned before, which is common factor factorization, it says that basically if we have two terms, which in this case we do have terms, right? Two terms, because as I said, a term is separated by an addition, a plus sign or a minus sign, and in this case we are separated by plus there. So now that means x plus 2 and x plus 2 here are actually a common factor. And so what do we usually do in the previous part that we were explaining? We would take the common factor and move it in front, and so that's why we have x plus 2 in front. But then whatever is left off, which is the 3x and the plus 4, then we put them together as is into the other bracket, and that would be our final answer. And this method that we just use is what we call grouping in pairs, right? And it's quite telling what it means, right? What we did here, we separated here, and then we grouped them into two pairs, right? Into a pair, right? And then after that we used common factor factorization all the way until we found the answer at the end, right? And so here is stuff you could try out, but I'll do A and F, and then the rest you can try it on your own. But here we have 2ab plus x of a plus b again. A plus b is a common factor, so you take it out in front, so it's a plus b, and then whatever is left is 2 plus x, right? And so it's 2 plus x. And then here again you do see that it's q minus 2 and q minus 2, which is the common factor, so we put it in front. And also what is left off, you're left with q minus 2. But q minus 2 and q minus 2 is the same, so you could also write it as q minus 2 to the power 2, which is still the same thing. Okay, so again, we will look at only these ones that are highlighted, but again, as here, you should stop the video and try the ones that I have not done, and here as well. Okay, so here is the exercises that you could try out. So the ones that I will focus on very directly is all of these ones. So we do B and C, right? So with B we have 3a plus 3b plus ax plus bx, right? Now in this case, what is the common factor for this pair? It's 3, right? And when you take out 3, then you're left with ab. But then here again, you are given ax plus bx. But now, what is the common factor in this case? It's x. So I take out x, and then you'll be left with a plus b. So now it is 3a plus b plus x of a plus b. But now a plus b and a plus b are common factors, so we put it in front, and then whatever is left off, we put it into the second bracket, right? And then here's a very interesting one where I'd like to also show you two different ways, and also it applies for all of them as well. It depends in the way you pair them or rearrange the terms, right? So it's mn plus 3np plus 5m plus 15p. Now what actually happens is that if you notice, I can say n, and n is my common factor for the first two pairs. So the first two pairs then will give me m plus 3p, right? But then I could also say here that my common factors in this case is 5, right? I can see 5. So it's 5. So I take out 5 and then it's m plus 3p. But now we do have m plus 3p to be the common factor. So we will take it out, and so it will be m plus 3p, and whatever is left off, we put into the second bracket, which is n plus 2, n plus 5. And then what do we see? Now what can we do? Now if we have mn plus 3np plus 5m plus 15p, notice that I can actually rearrange these numbers, right? How about if I say to myself, no man, for the first two pairs, which is this two, I want to put where I have m as my common factor, right? So I paired mn with plus 5m, but also here I paired 3np plus 15p, right? But now in this case, what's actually happening? I actually see that I actually have m and m to be my common factor, so I take it out, then I'll be left with n plus 5. And then in the second pair, I can see that my common factor is 3p, so I take out 3p, and then it will be n plus 5, right? And you can see we have n plus 5 and n plus 5. It's a common factor, we take it out in front, and then once we have it in front, then we'll be left with m plus 3p. But then if it's m plus 3p, that's what we get. The only difference between the two is the order, and as you can see, the order does not matter if you think about the associativity property of fractions. Okay, so this is still correct, and so you must be careful and you must be aware that even when you rearrange them, you will still get the same answer as long as you do it correctly in terms of factorizing the common factor factorization as you do the problem, right? And so you can look at the other ones as well. I will not explain these ones. So yeah, these are just other ones you can also look at as you go along. So you just have to stop the video and continue. And now we would look at factorizing using the difference of two squares. So factorizing using the difference of two squares, what we do have here, we have x squared minus 4, right? Now x squared minus 4 has a very interesting relationship that, one, they are a difference. What do we mean by difference? It means that there's a subtraction between two numbers or two terms, right? Now if there's a subtraction between two terms, and what kind of terms are these? Now, as the name states, it says the difference of two squares, and the squares basically refers to the fact that the two terms, and remember what I said about a term is separated by a plus or a minus. In this case, it's separated by a minus. So we have the first term and the second term. So these two terms, this first term has x to the power 2. And then we have 4, but 4, remember, it's actually 2 to the power 2. So if you have x to the power 2 subtracted by 4 to the power 2, then what does that tell you? It tells you that it is a difference of two squares. And if it's a difference of two squares, then the factorization that we apply is that we will have x minus 2 and x plus 2. And so that is basically how we do it. It will always give you x minus 2 or x plus 2. So if it was x squared minus 9, it would be actually x minus 3, x plus 3. You see, if it was x squared minus 25, remember 25 is actually 5 to the power 2. So if it was, let me write it down actually, if it was x squared minus 25, this 25 is actually, remember, it's 5 to the power 2, and since it's 5 to the power 2, then the factorization is supposed to be x minus 5, x plus 5. So what you could think of it as is that you are actually just going to ignore the root, the power signs at the top, and then what you'd say is just x minus 5. It's almost like you're rewriting it without the squares at the top, right? And so it'd be like x minus 5, and then you just change the sign and make it plus again, and then you say x plus 5, and that's your answer. So that's how you do this type of factorization. It's very straightforward, not too difficult again. So here are some exercises that you can try it on your own, but I have C, K, N, and P, which is done in the video. So here we have m to the power 2 minus 25, and we find that that's m minus 5, m plus 5, right? We have x squared minus 8 to the power 2. Both of them are difference of two squares. Therefore, we have x minus a and x plus a, right? Again, as I said, it's like you are going to ignore the squares at the top, and then you say it's x minus a as is, and then you would have to change this sign and just put a positive side, so it would be x plus a. And then we have 16x squared minus 1. Now with this one here, it is actually, remember, it's 4 to the power 2 and x to the power 2 minus 1 to the power 2, right? And so you could just write it as 4x minus 1, so it's 4x minus 1, and then you say 4x plus 1. Here you have 7 squared, right, minus 2 squared to the 2 squared and a squared, and so you have squares everywhere, and then you say it's 7 minus 2a, and there we have 7 minus 2a, and then it's going to be 7 plus 2a, and that would be your answer there. Okay, and so here's more examples that you could try out and do on your own. And so it's still the same idea, but now the only difference is that you need to maybe do 1 or 2 more steps. So in this case, you have 2x squared minus 32. Now it's not so clear if it's a difference of 2 squares. So what do you do first? You can actually see that there is a commonality between the two terms, right? And that is 2. So if I take out the 2, I actually find that I have x squared minus 16, but 16 is actually 4 to the power 2. So if it's 4 to the power 2, then it's just x minus 4, x plus 4, right? And the same thing applies for the rest, right? You just look for the common factor and then you work it out. And then there's just one thing that I would like to just mention, and that is the difference of 2 cubes, right? And the difference of 2 cubes is basically that if you have a to the power 3 minus b to the power 3, right? Then that should give you a minus b, and then a squared plus ab plus b squared. And basically this a square here is basically what you're gonna put in to make it 3a there, right? But then you say plus and plus, but this ab here is actually just the product of what is inside here, so you say it's a times b, right? And then you can also see here you have x to the power 3 minus 8, and so it's x to the power 3 minus 2 to the power 3, and that would be just x minus 2, but then you write in x to the power 2 so that we can make x to the power 3 there. And also when we see that we must just multiply these two together, but we always place in a plus, and then it's just 2x plus 4, and this 4, remember, is actually 2 to the power 2, because 4 times 2 would give us the 8 that we are looking for, or which is 2 to the power 3. Okay, and then the last one, which is factorizing using the quadratic trinomials. So we have x squared plus 5x plus 6, and so how do we get x plus 3, x plus 2? So the idea is that you first have to look at the last term, and the last term here is 6, right? And so the last term, if it is 6, or let me not say the last term, because this could have been written as 6 plus 5x plus x squared, right? So what you actually do is you look for the term that actually has that does not have a variable, right? You first look at the term that does not have a variable, but you only look at that term first when and only when x squared does not have a coefficient. I mean, it only has a coefficient 1. Okay, so yeah, it is just 6. So you go and look at 6, and you look at 6 and you think to yourself, what are the numbers that I can multiply together to give me 6, but when I add together, that should give me 5. Now in this case, as you can see in orange, it's 2 times 3, which 2 times 3 does give you 6. But then when you say 2 plus 3, it does give you 5. So that satisfies that. So that's why we would say we have x times x to give us x squared. But then the 3 and 2, we say it's plus 3, because plus 3 times plus 2 would give us plus 6. And also at the same time, plus 3 times x plus 3 times x, right, would give us 3x, but also 2x, x times 2 would give us 2x. So when we had to like expand this, then we would have 3x plus 2x, which gives us 5x, and that's why we would have x squared plus 5x. But let me expand it so that you can see that it does work, right? So when you do this expansion, you'd do like this way. You'd have x times x times 2, 3 times x, 3 times 6. So here you'd have x squared, right, in the first one, which is x times x, so it's just x squared, and then x times 2, that's just 2x, right? And then you have 3 times x, which is just 3x, and then it's 2 times 6, 3 times 2, which is just 6. And so here, then when you rearrange, or when you add the like terms, it's 2x plus 3x, and that just gives you 5x plus 6, and that you can see is the same. So we did factorize it correctly. Okay, and same thing applies here. When you look at x squared plus 7x plus 10, what do? We look at the last term. What are the two numbers that we can multiply together to give us 10? But then what are the numbers again that we can add together to give us 7? So 2 times 5 does give us 10, but 2 plus 5 does give us 7, and that's why it's x plus 2, x plus 5. But something you should notice is why we put just x, because the x and the x in both the brackets, they're supposed to give us x squared. That's why we just put in x, and then the only difficulty is that you just need to find the number at which you need to place on the other side, which is 2 and 5, right? So here are some exercises that you can try on your own, and the only 3 that I'll do is S, I, and K, and then the rest you can try it on your own. So here you can see I is x squared minus 3x minus 4, and you find that it is x minus 4, x plus 1, right? Because 1 times 4 does give us 4, but if we say 4 minus 1, that does give us 3. And same thing, k squared minus 5k plus 6, it's k plus 6, k minus 1, and then you also find that. Now k, number k, where we have 3a squared, 15a minus 180. What you should notice is that 1, you have 3a squared minus 15a minus 108, right? You have a common factor, so you can take out 3, and when you take out 3, you do get that it's a squared minus 5a minus 36. But then what are the two numbers that you can multiply together to give you 36? It's 9 and 4, and what it is, when we add them together, where it's minus 9 plus 4, it does give us minus 5, and that would be our factorization for that. Other than that, I'd really like to thank you for watching this video. I hope this was helpful, and I hope that you do try the exercises in this video. Other than that, see you next time.